Hi, my name is Julieta Diaz and I am a data scientist at TIBCO. Welcome to this Team Studio enablement video. In this video, I will cover how to use Team Studio to solve a regression problem. We are going to use the Elastic-Net Linear Regression and the Random Forest Regression operators, among others. We are starting from the Work Files tab in a workspace I have previously created, and we will click on the regression workflow to get to the workflow canvas you can see here. In the regression problems, we are trying to estimate some kind of continuous variable, some kind of number. That's the output that we expect from our models. For example, I have the famous wine quality dataset here. This dataset is related to wide variants of a Portuguese wine, and it contains information about the wine. Things like the pH, density, residual sugar, alcohol, acidity, etc. What we want to predict is the quality of the wine, based on the information that we have about these wines. The variable quality represents a score and assumes values between 0 and 10. This dataset can be viewed as a classification or a regression task, but in this case, we will consider it as a regression problem. I have already split the data into a train and test set, so we are ready to drop into the canvas our regression models. The way you can find out what models are available to you is by looking at the operator menu on the left-hand side, and if you select models, you will have a list of all the different models that you could use. For our purposes, we need anything that has the word regression in it, because we are predicting the quality of the wine, a continuous variable. In this case, I want to try out a random forest and I want to compare that to an Elastic-Net Linear Regression model. I want to see which one of these two will give me a better prediction, closer to the actual values that we have. We need to connect the training data to each of the models. And then for the random forest regression, if I check the operator properties, we need to specify the dependent column. So in this case, that will be the quality. That's the part that we are predicting. For the columns, I'm going to just select all in this case, although you could unselect some columns here as well if you have more knowledge about your dataset, that maybe some things are not so applicable. As you can see, there are some more parameters here that we could configure, but for our purposes, I will leave them as per default. If you would like to know more, you can always click on the question mark here on the right-hand side. That will take you straight to the typical documentation on the operator, and it will tell you things like what the parameters mean and their configuration, or default values, if any. As part of this series of Team Studio enablement video, you can find a specific video about the random forest operator, where we go through each one of the parameters and we explain them in detail. In this case, let's press OK and look at the Elastic-Net Linear Regression operator. Elastic-Net is a combination of the two most popular regularized variants of linear regression, Ridge and Lasso. Ridge uses an L2 penalty and Lasso uses an L1 penalty. With Elastic-Net, you don't have to choose between these two models because it combines both penalties. Again, we have to select the dependent column, so that's quality, and we are going to select all of the columns as before. We are comparing the two models, so it will be good to have the same features going into both of the different models. There are more parameters we can modify, like specifying if we want to normalize the numerical features, the metric for evaluating the model, how many iterations we would like to do for each grid of parameters, how many cross-validation faults, etc. I'm going to leave it as per default, but if you would like more information, you can always click on the question mark on the right-hand side. Once we have created and configured the models in Teams Studio, the predictor operator needs to be connected to the models if we want to create some predictions for our testing set. So here, the input to the predictor is the test set and then the different models that we will have to create predictions for. And then, to compare the two against each other, we need to have an evaluator, and in this case, we have this operator called the regression evaluator, which calculates several metrics for evaluating the regression models. If we open up the properties, you will see that the actual value must be put in. So in this case, it's quality. I'm going to click OK and then run the whole flow. Once the analytical flow has finished, we can check back at our operators and we will see that there is some output that is created within the models themselves. So for example, in the linear regression output, we can see the coefficients of the different variables that are input into the model. And in the training summary, we have a table with a row for each of the tested combinations of hyperparameters, along with the metric and the best model. If you look at the output of the predictor operator, we can notice that with each of the models, there is a column that appears, which is called pred and contains the numerical predictions. RFR refers to Random Forest Regression and LR refers to Linear Regression, as you can see in the summary section. So we can see that, for instance, in the first one, the linear regression came much closer to predicting the level than the forest. So we can just keep going along and see all of the different predictions. Finally, we will check the results of the regression evaluator operator. Here we can see the metrics values for each of the models. In this case, the performance of the models was very similar, but the values of the random forest are slightly lower than the linear regression. So we can say that the random forest model was better. Thank you for watching.